Yes, Navya, just tell me which assignment you are having problem in. I'll discuss those assignments.
Ma'am, the assignment given on Sunday, the second one.
This circular motion one?
Yeah, ma'am.
Just wait. Okay, let me discuss a little bit topic from this and then I'll discuss the assignment. Okay. See, dynamics of uniform circular motion we had to start. Just tell me one thing. Could you write down this part in the last class? Yesterday? Could you copy it?
No, ma'am.
Okay. So you were writing this part. Please just copy this first. Okay, so see, now talking about the dynamics of uniform circular motion, the concept of the centripetal force class. See, centripetal acceleration we have discussed. Now look, whenever you have centripetal acceleration or any sort of acceleration class, you know force is equal to mass into acceleration, right? So force will be mass into centripetal acceleration. Centripetal acceleration we already know. This is v square by r. So this will be mv square by r. This is the centripetal force. Okay, mv square by r. So any force that acts along the radius and towards the center, any force in the system can be said to provide the centripetal force. So whichever, see, force required to change the direction of velocity, it provides a centripetal acceleration. These are the two most important points which you need to remember, that it acts along the radius and towards the center, like this. It acts along the radius and towards the center. So this is the centripetal force present acting along the radius and towards the center. Now any force that is present which if it acts along the radius and towards the center will provide the necessary centripetal force. Now see, planets revolving around the sun. Sun is there, earth is there, separation between them is present. So if we have gravitational force, if we have centripetal force, means gravitational force is present between the sun and the earth. Now see class, gravitational force is present between the sun and earth, but it is acting along the radius and towards the center, right? So if it is acting along the radius towards the center, gravitational force is g m1 m2 by r square. This we'll study in the gravitation chapter. Now what happens? Sun exerts a force of gravitation along the radius and towards the center like this. So if this is the case, so what will happen? We will have the centripetal force as mv square by r. Means the gravitational force will provide the necessary centripetal force. Okay. Similarly, let's say we have the electron and nucleus is there. Electron is revolving around the nucleus. So we'll have the electrostatic force here. This electrostatic force you will study in class 12th. So K Q1 Q2 divided by R square is present. So in this case, we'll have the centripetal force will be provided by the electrostatic force. So we'll equate these mv square by r. Similarly, in the laws of motion chapter, we'll see that the cars have the tendency to skid away. So frictional force acts in the center. So frictional force is mu n and the centripetal force is mv square by r. So in this case, frictional force will provide the necessary centripetal force. So any force that is acting along the radius and towards the center, whether it's your electrostatic force, centripetal force, the frictional force, the gravitational force, it is said to be providing the centripetal force. So any force that acts along the radius and towards the center is termed as the centripetal force. Okay, so we'll see numericals also based on this. One question let me discuss. This says that a body of mass 10 kg is moving on a circular track of radius 5 meter with a velocity of 2 meter per second. So centripetal force will be mv square by r, which is 10 into 4 divided by 5. This is equal to 2. Centripetal force will be 8 Newton. Like this, mv square by r is the formula, mass into the acceleration. Fine. Write it from here, dynamics of circular motion. And after this, before centrifugal force, I'll discuss the assignments. So regarding the assignments of the circular motion only, no, Nabiha, you are referring to. Which
Yeah,
one? You
ma'am.
had the
Circular
circular.
motion.
Okay. I'll discuss it after this. Nabia, is it from friction? The assignment which you are referring to?
What, ma'am?
Is the assignment which you are referring to is from the chapter, from the topic friction?
No, ma'am, it's this central acceleration one. The one that was given on Sunday.
Can you just tell me the name of the assignment?
Yeah, ma'am, just in a second.
Oh,
It's uniform circular motion, ma'am.
okay, Nabia. Okay, see, this was the sign. Nabia, you were referring to this assignment, uniform circular motion. This one.
Yeah, ma'am, this one.
Okay. Okay, the first question says, which is greater, the angular velocity of our hand of a watch or angular velocity of Earth around its own axis? See, what's the formula of angular velocity when we refer to? Angular velocity is displacement divided by time. Now, see, when we talk about the watch, you have the hour clock or you have the hour hand and the minute hand present. Complete angle that is taken by the hour clock is 360 degree. It doesn't happen, no, that your clock stops at 6 o'clock and then back to 12. It completes one complete rotation. So angle here will be 360 degree. Now degrees we don't use. We use 2 pi radian. So the displacement will be 2 pi radian. Let's talk about Earth. When we are talking about the Earth, Earth is also rotating about in its own axis. So again, the total angle that is covered by the Earth is 360 degree. That is 2 pi radian. Okay. Now see, here this upper part means the numerator is the same in both the cases. Theta is also 360. This is also 360. It says which is greater. So we will have to look up to the time, which one is greater. See, for the time here, if you look, the hour clock, it just covers 12 hours. It doesn't cover 24 hours in this time only. When it covers 24 hours, then there are two rounds for a watch, for a clock, if you see. It starts from 12, then till 12 noon, that's 12 hours only. And the angle is already completed up to 2 pi radian. And when you talk about the Earth, Earth completes 2 pi in 24 hours, while the watch completes 2 pi radian, means 360 degree in just 12 hours. In the second round, no, it repeats itself. So time is different. So omega is inversely proportional to the time. The time is more in case of Earth, so angular velocity will be less. Time is lesser for a watch, angular velocity will be more. So which one is greater? The clock. This angular velocity of our hand of a watch will be greater. Okay, that's the first question. Second is find the magnitude of centripetal acceleration of a particle on the tip of a fan blade, 0.3 meter in diameter, rotating at 1200 revolutions per minute. See, fan is there. These are the blades of fan. See, one blade is, this is 0.3 meter long. And angular velocity is 1200 revolutions per minute. Means I have told you multiplied by pi by 30. So this makes it 40 pi. So radius is equal to 0.3 meter, while the angular velocity is equal to 40 pi radian per second square. Now it says calculate centripetal acceleration. Centripetal acceleration is omega square into r. Use this formula. You will get this. Omega is here, r is here, omega square r. Then this is an insect trapped in a circular groove of radius 12 centimeter, moves along the groove steadily and completes 7 revolutions in 100 seconds. Okay, this completes 7 revolutions in 100 seconds. It says what is the angular speed and the linear speed of the motion. Fine. So see, 7 revolutions in 100 seconds means in 1 second how much revolution will be there. You can calculate that. Radius is already given. It's a very, very easy question. Insect trapped in a circular groove of radius. Radius is given as 12 centimeter. You can say 0.12 meters. Moves along a steady groove steadily and completes 7 revolutions in 100 seconds. Means what's the angular velocity? 7 revolutions in 100 seconds. Means 100 seconds are providing 7 revolutions. 1 second will have 0.07 revolutions. So that is revolutions in second. So if 1 second has 0.07 revolution, we can say 1 second has 0.07 into 2 pi radians. So you have the whole displacement, angular radian per second, sorry. And this is radius is already there. Angular speed, linear speed, very easy. Angular speed, omega. This is omega. 7 revolutions in 1 second. This is what we have got. And linear speed, v is equal to omega into r. Use this. This is already omega present. This is omega r. Is the acceleration vector a constant vector? What is the magnitude? Now acceleration omega is constant. Omega is not changing. So acceleration is also constant. What is its linear displacement? You have velocity. Is the time given? 100 seconds is the time. Velocity is there. Time is 100 seconds. Calculate the displacement. Displacement is equal to, see, speed is equal to distance divided by time. Distance will be speed multiplied by the time. You multiply both of these. Got it? Nabiha?
Yeah, ma'am, understood.
Okay, quickly just write down the key pointers so that you can copy. Then we'll come back to the chapter. Okay, see, let's talk about the centrifugal force. So we already talked about the pseudo force. So centrifugal force is also one of the pseudo forces. Centripetal force can act in any frame, means in the inertial frame, but centrifugal force acts in the non-inertial frame. Non-inertial frame means the frame is also rotating. Like let's say a car is moving on a circular track. So the circular tracks do not rotate. So that's why you have the centripetal force acting over there. But if you sit in a merry-go-round, that also rotates when you're sitting there. So there an outward force is felt that is known as the centrifugal force. This is also along the radial path only. Okay, this is along the radial path itself. But this is acting away from the center. Okay, so it acts in the rotating frame, pseudo force. Direction is along the radius but away from the center. The false force, but formula is still the same. mv square divided by r. It's not a reaction of the centripetal force. Now, the last part of this chapter also and the circular motion topic also, that is regarding the maximum speed. Whenever circular tracks are present, so there we have the speed limits present. Those speed limits cannot be crossed, like 50 kilometer per hour, 20 kilometer per hour. Like this, the speeds cannot be crossed. In every vehicle, for every vehicle, there are different speed limits. If you have ever been to a hilly place, you must have seen there are certain speed limits because of the skidding away of the cars. If the speed is increased and the enough centripetal force, whichever is needed, that has been crossed. If the velocity is exceeded, the car has a tendency to skid away, and it can then definitely it can fall off. That's why the safe limit is present, and this is lower than what is there on the normal straight roads. So that we have to calculate, and we'll see. The reason is that friction force acts and it supports maximum velocity with which the body can move on a circular track. If this velocity is exceeded, the car will skid. Now we'll discuss about the bending of road. Just write about the centrifugal force. Then we'll discuss about the bending of road, banking of road, 2.5. Regarding this bending of the road, bending of road means a circular track has been formed. Now see, a vehicle is present. Downwards, we have the gravitational force acting. Upwards, we'll have the normal reaction. Okay. Now the body has the tendency to skid away, to skid outside. So a centrifugal force will be acting over here, while the frictional force will act inwards. So this is how the forces are acting. And see, very easily we can say which forces are balancing which force. If you look, the normal reaction is upwards. It's basically, see, upward forces will balance the downward forces, leftward forces will balance the rightward forces, like this. Okay, left, right, up and down. These will balance each other. If a force is acting in some different direction, we have to resolve it and then we have to check this. So this is how you have to remember all of it. Now you can simply say from this, the frictional force is balancing the centrifugal force. That is mu n is equal to mv square by r. That is your first equation. Normal reaction is balancing this mg. That is the second equation. Let's divide both of these. We will get mu n by n is equal to this term divided by this term. mv square by r into mg. Mm will be cancelled, N will be cancelled. What is left? Velocity is equal to under root mu r g. This is the velocity. In fact, this is the maximum velocity, which is known as the safe limit. Okay, this is known as the safe limit. V is equal to under root mu r. Let's look at a question. This says a car is moving on a circular track of radius 100 meter. Radius is given as 100 meter. Coefficient is given as 0.4. Calculate the safe limit. V is equal to under root mu rg. So V will be 0.4 into 100 into 10. This becomes root 400. That is equal to 20 meter per second. Okay. This is one question. Let's see one more. This is on a rainy day, coefficient of friction decreases to 0.2. Calculate the safe limit. Yes, Mariam, what's the formula? Which formula should I apply, Mariam? Mariam, the formula is written on the screen. Look at the above question. V is equal to under root mu rg. What are we discussing? Okay, just tell me what was the topic that we were discussing? Mariam, you're there?
Yes, miss.
Which topic we were discussing? Please pay attention in the class. This says on a rainy day, coefficient of friction decreases to 0.2. You have to calculate the safe limit. Radius is equal to 100 meter. Okay. So, okay, I'll discuss this question. First, start writing from here. Let Tahura join also. Then I'll discuss. This is there. Yes, Tahura. Is your network fine now? Tahura. Yes, Tahura, respond. You there or not? Okay, you're not able to open mic. Okay, then use the chat box. It's okay. I'll read it. I don't know why you are. Mariam was able to do. Others are able to open the mic. No? Okay. Yes, Tahura, what we were discussing? What was the topic? Tell me in the chat box. Type it only. What was the topic that we were discussing? Yes, Taura. I am asking what was the topic? Which topic are we studying? Yes, tell me. Topic, which topic we are studying? She left. I knew she'll leave. So velocity is, please pay attention class. During the classes, at least pay attention. I give you sufficient time to copy. At least basics you should know what we are doing in the class. These are formula based questions which we are discussing. It will affect your score. Velocity is equal to under root mu rg. This is the safe limit. Safe limit of the car. Means if this velocity is crossed, car will skid away. Formula is under root mu rg. Am I now clear, Mariam and Nabiha, both of you?
Yeah, ma'am.
Mariam, to you too?
Yes, miss.
All right. So see, mu means coefficient of friction, that is 0.2. Radius is 100, this is 10. Solving part properly, I know you'll be able to do. That is under root 200 meter per second. That's the velocity. Okay. Write it. Start writing from here. Yes, Nadia, just text me a done once completed, okay?